Welcome everyone. Today we're going to be looking at section B of Progress Test C. I'm going to be working through the multiple choice questions with you, and hopefully this will help you with your to support your revision. Let's have a look at question 9, which is an enthalpy profile diagram question for a reversible reaction. So let's look at which statement about this reaction is correct. A tells us that the activation energy of the forward reaction is 120. Well, we should know that the forward reaction, the activation energy is 150 for the forward reaction, so A is incorrect. B, the activation energy for the reverse reaction is 270 kilojoules per mole. So, from the products going back through the reactants, the activation energy will be that value, which is 120 plus 150, which gives us a value of 270 kilojoules per mole, which means that B is correct. C cannot be correct because the enthalpy change of the forward reaction is, from the reactants to the products, is minus 120. And the reverse reaction is exothermic is not correct either, because the reverse reaction will be endothermic. It will have a positive energy change. So that's question 9. Question 10. Which statement about an electrophile is correct? This is give the definition of an electrophile and move on. What is an electrophile? If you know your definitions, an electrophile is an electron pair acceptor. It's not a proton donor, that's an acid. It is not a negative ion. It's not going to accept a pair of electrons. It's a negative ion. And it is not a species with an unpaired electron, because that is called a radical. Question 11. Which statement about infrared radiation is not correct? Let's have a look through them all. The energy from infrared radiation causes some covalent bonds to vibrate more. We know that that does that. Absorption of infrared radiation by atmospheric gases is linked to global warming. We know that's true. Infrared radiation is used to monitor gases causing air pollution. That is also true. So D must be incorrect. And the action of infrared radiation on CFCs does not lead to the formation of chlorine radicals, because it's the action of UV light that does that. Question 12 is about producing nitrogen dioxide from ammonia and the air. And we're given two equations. And then we're given an overall equation and asked to calculate the enthalpy change for this. Now, the important thing about answering this question is to realize that if I times the second equation here by 2 to give me 4NO plus 2O2 goes to 4NO2, and then I combine both equations, this one and this one, the 4NOs cancel out on each side, and I end up with 4NH3 plus 7O2 gives me 4NO2 plus 6H2O, which is the equation we're looking for. And the calculation that needs to be done then is minus 909 plus 2 times minus 115, which equals minus 1139 kilojoules per mole. And the answer to that is D. Moving on to the next question, which is question 13. This is about knowing your organic testing. A, propan-1-ol will it react with sodium hydrogen carbonate? No, we're looking for correct observations in this question. Propanal, will it react with sodium hydrogen carbonate? No, we're looking for a carboxylic acid to do that. Will it react with acidified potassium dichromate? That's the correct observation. It will be oxidized from orange to green. And will an aldehyde react with Hallam's reagent? Of course it will. It will produce a silver mirror. So we know that B is the correct set of observations, and B is the correct answer for that. C is a ketone. It will not produce a silver mirror with Hallam's reagent and propanoic acid. The test for a carboxylic acid is that it will effervesce or fizz with sodium hydrogen carbonate. But propanoic acid will not form a silver mirror. So again, the correct answer to question 13 is B. Question 14 is a calculation based on the breakdown of ozone. Now, it's important to notice here that 2 moles of ozone are breaking down to produce 3 moles of oxygen. And when 2 moles of ozone break down, the enthalpy change is -2, we have 4. When 1 mole of ozone breaks down, -142 kilojoules per mole. So we're looking at the energy released in kilojoules during the breakdown of 1 meter cubed of ozone, when we know that 1 mole of ozone occupies 2.5 meter cubed. So 1 mole of ozone occupies 2.5 meter cubed. The number of moles of ozone equals 1.0 divided by 2.5. That's my moles. If I multiply that by the enthalpy change per mole, I can leave it as plus 142 because they have mentioned that it's the energy released. So I'm taking away the negative sign. Released means that it is exothermic. 1 divided by 2.5 multiplied by 142 gives me 56.8 kilojoules of energy released. And your answer there is A. Question 16. Which equation does not represent a redox reaction? So metal plus acid is always a redox reaction. So A is a redox reaction. The magnesium is going from 0 to +2. B is a combustion reaction. Combustions are also always redox reactions. A GCSE would have been known as a displacement reaction, but there is an oxidation number change from 0 to +2 in the iron and +2 to 0 in the copper, so that's a redox reaction. D is a neutralization. Neutralizations do not involve any oxidation number changes, so D is not a redox reaction. Acid plus base goes to salt and water. And that's question 15. Question 16 is, what is the percentage yield when 20 grams of aluminium are produced from 50 grams of aluminium oxide? So, percentage yield is actual, I'm going to use moles, divided by theoretical moles, multiplied by 100. The actual yield of aluminium is 20 divided by 27, which is 0.741 moles. The theoretical yield, we need to use the aluminium oxide to work out the theoretical yield, is 50 divided by 102, which is the formula mass of aluminium oxide. We're going to multiply that by 2 because the mole ratio is 2 to 4, which gives me a theoretical yield of 0.98 moles. If I divide the 2 and multiply by 100, this will give me my theoretical yield. And the theoretical yield for question 16 is 76%, which is A. Question 17 is which compound can be oxidized to form this compound, which is a ketone. Now, I would like to draw this compound out first of all to help us with this question. So if I draw it out, I have a CH3 attached to a carbon, attached to a hydrogen, attached to a CH3, attached to a C double bond O, attached to a CH3. Now, what compound there would be oxidized to produce that? Well, it's going to be a secondary alcohol, yeah? And the OH will be on the second carbon, so it's going to be a butan-2-ol. If the OH is on the second carbon, it means that the methyl group must be on the third carbon. So it's 3-methyl butan-2-ol that would oxidize to form that product. Question 18. A drink driving offence is committed if the blood alcohol level of a driver is over 80 milligrams of ethanol per 100 centimetre cubed of blood. What is the concentration in moles per decimetre cubed of ethanol if there are 80 milligrams of ethanol per 100 centimetre cubed of blood? This is a calculation involving number of moles divided by volume to work out the concentration. Initially, we need to work out the number of moles using our mass. So the number of moles of ethanol is 80 by 10 to the minus 3, because I'm converting the milligrams into grams, divided by 46. That is my number of moles of ethanol. Concentration equals number of moles divided by volume, and the volume must be in decimetre cubed. So if I divide that by 0.1, which is my decimetre cubed, that will give me my concentration, and the concentration is 0.017. moles per decimetre cubed. Okay, number 19. Which compound has the highest boiling point? This question is about intermolecular forces. Between molecules. A has a permanent dipole. B has a permanent dipole. C is an aldehyde that also has a permanent dipole. But D, a carboxylic acid, will have hydrogen bonding. And hydrogen bonding is the strongest intermolecular force. So hydrogen bonding between molecules of a carboxylic acid will in fact give it the highest boiling point. So the answer to that one is D. So moving on to the next question, which is question 20, about infrared spectrometry. And it's the infrared spectrum of an organic compound is shown, and we're given the spectrum, and we're asked to work out which compound produces this spectrum. Now it's important that you use the data sheet for this to get to the right answer. So The easiest mistake to make for this question is to automatically assume that it's a carboxylic acid. And the reason you would assume that it's a carboxylic acid is because you have an OH peak here and you have a C double bond O peak. But the OH peak is further to the left than it would be for a carboxylic acid, and it is a distinct broad peak. And it's at the peak is at the wave number for an alcohol or an OH group in an alcohol. So this is not a carboxylic acid spectrum, it is a hydroxy ketone spectrum, and the answer to the question is B, 4-hydroxy butanol, which has a C double bond O and an OH as part of the hydroxy. The OH peak is too far to the left to be that for a carboxylic acid. Trick question, very tricky, but the answer is B, 4-hydroxy butanol. How many isomers are there of C3H9N? So what we're looking at here is amines. And the simplest one we can draw is 3 carbons long. One aminopropane. We can also have two aminopropane. We can then look at secondary amines, and we can have an N here with a H and a CH3 there, and a CH2, CH3 there, which gives me 3 structures. That's 1, 2, 3. There's also another structure that is possible, which would be a tertiary amine with the nitrogen attached to 3 different groups. Which gives us 4 possible structures for C3H9N. So the answer to number 21 is C. Question number 22 involves looking at the definition of a nucleophile. And in order to be a nucleophile is an electron pair donor. So we need a species with a free electron pair. The ammonium ion does not have a free electron pair because the lone pair in the nitrogen is bonded to a proton. So that cannot be a nucleophile. As there's no lone pair. Methane. There's no lone pair on the carbon or the hydrogen. A proton has no electrons at all. So that cannot be correct. The only one it's possible that the answer could be is methanol. And with methanol, remember that the oxygen has 2 lone pairs on the oxygen, which allows it to act as a nucleophile. So for question 22, the only option for the nucleophile is B. And last but not least is question 23. What is the percentage composition by mass of nitrogen in ammonium carbonate, NH4 twice CO3? Well, there are 2 nitrogen atoms, which gives us a mass of 28 for the nitrogen, 2 times 14. And we need to divide that by the total molar mass, which is 14 plus 4 is 18. 2 18s are 36. Plus 12 is 48. 48 plus 48 is, the 3 oxygens is 96. So it's 28 divided by 96 multiplied by 100 to give us an answer of 29.17%, which is C. Now, I hope that that has provided some help for you in terms of answering these multiple choice questions, and you will be able to use what you have learnt in the future when you're doing your chemistry exams. All the very best. Take care. Bye.